Hello, this is 10-6, theoretical probability. The first thing we need to define is what does it mean to have equally likely outcomes? And that's what we need to have when we're talking about theoretical probability. So if we look at these two spinners here, the first one on the left represents equally likely outcomes, meaning that there's the same chance the spinner will land on any of the colors. If you look at the one on the right, those are not equally likely outcomes because blue covers more area than the rest of them, so there's a greater chance that it would land on blue than any other color. When we're dealing with theoretical probability, we need equally likely outcomes. So the theoretical probability of an event is the ratio of the number of ways the event can occur over the total number of equally likely outcomes. Alright? So it's similar to experimental probability, except for we're not actually performing the experiment. We are just in theory thinking about what would the probability be if we did these experiments. So for example, we have an experiment consists of rolling a number cube. Find the theoretical probability of each outcome. Alright? Well, a number cube has, 6 numbers on it. 1, 2, 3, 4, 5, 6. What would the theoretical probability be of rolling a 5? Well, there's 1 5 on there, so that's going to go on top. And then how many equally likely outcomes are there? There's 6. So the theoretical probability of rolling a 5 would be 1/6. What about the theoretical probability of rolling an odd number? Well, there's still 6 sides. How many odd numbers are there? Well, 1, 3, and 5. So there's 3 odd numbers. So we'd have a 3 out of 6 chance of getting an odd number, or 1/2. Okay, what about the probability of rolling a number less than 3? Well, again, we still have 6 possibilities. How many of those are less than 3? Well, just 1 and 2. So we'd have 2 out of 6 chance, or 1/3 of a chance of rolling a 3. So that's how we figure out theoretical probability. Now, something you should know about probability here, let's just talk about when I'm tossing a coin. There's 2 possible outcomes, heads or tails. The table below shows the theoretical probabilities and the experimental results of tossing a coin 10 times. So the top row there, we tossed it 10 times, we got 3 heads and 7 tails. Notice if we add up our results, we will get 1. The same is true for our theoretical probability. 1/2 plus 1/2 is 1. So this can be helpful to us to know that the sum of the probability of your equally likely outcomes will always be 1. Okay? Because there is going to be an outcome. So there's a 100% chance that an outcome will happen. So you have the probability of the event happening plus the probability of the event not happening always equals 1. And we can use this to help us figure out some problems. Now this is also sometimes called the complement. Okay, so the complement of an event is the outcomes that are not part of the event. So the probability of the event and the probability of the complement of the event is 1. And that's essentially what the previous slide just said, just with fancy math words instead. So let's say we have a box contains red, black, and white blocks. The probability of choosing a red block is 1/4. The probability of choosing a black block is 1/2. What's the probability of choosing a white block? Well, we know that the probability of choosing red plus the probability of choosing black plus the probability of choosing white has to equal 1. So those are the only 3 colors in the box. So if the probability of choosing red is 1/4, the probability of choosing black is 1/2. We don't know the probability of white, that's what we're looking for. And that's what P of W means. We can figure this just using a little bit of math here. So 1/4 plus 1/2 is 3/4. Plus the probability of white has to equal 1. So if we subtract 3/4 from each side, we can figure out that the probability of choosing white is 1/4. Okay, so we didn't even have to know how many blocks were there and how many of each type. We could just use the fact that they have to add up to 1 to figure out the probability of white. Okay, we can do the same thing here. We have a jar that has green, blue, purple, and white marbles. The probability of choosing green is 0.2, choosing blue is 0.3, choosing purple is 0.1. What's the probability of choosing white? So again, we know if we add up all those probabilities, we're going to get 1. So the probability of green is 0.2, probability of blue is 0.3, probability of purple is 0.1, and then we want the probability of white. So 0.2 plus 0.3 plus 0.1 is 0.6. So if we subtract 0.6 from each side, we can see that the probability of white has to be 0.4. Okay? So we can use that little fact there to help us figure out probabilities. Now the next thing we need to talk about are what are called odds. Okay? Now odds and probability are slightly different. Okay? Odds in favor of an event describe the likelihood that the event will occur. The odds against an event are the likelihood that the event will not occur. Usually we write these in colon form, A colon B, alright? And that's how you'll see them. Sometimes you can write A to B or A over B, but most of the time you're going to see them with a colon in the middle. And here's how we figure out odds. Odds in favor are the number of ways an event can happen over the number of ways that it can fail to happen. Now notice the difference here. Probability is when we have the number of ways the event happens over the total number of possible events. This is the number of ways the event happens to the number of ways that it doesn't happen. Alright, that's the major difference. So odds in favor looks like that. Odds against is the number of ways it fails to the number of ways it doesn't fail, essentially. Alright? So it just kind of reverses it. So let's look at some of these problems. Mainly we're going to be working on how do we convert between odds and probability. So the probability of rolling a 2 on a number cube is 1/6. What are the odds of rolling a 2? Remember, odds are the number of ways it can happen. So it can happen one way, right? There's only one way to get a 2. To the number of ways that it doesn't happen. Okay? Well, there's 5 other ways to not get a 2. So the odds of rolling a 2 would be 1 to 5. Now notice that the odds, the two numbers that we use when we write the odds, will always add up to the total number of possible events, the 6 there that we have in the probability. Okay? Let's look at another one. The odds in favor of winning a contest are 1 to 9. That means there's one way to win it, 9 ways to lose it. What's the probability of winning the contest? Well, the probability is how many ways can it happen over the total number of ways. Okay? Well, there's one way to win, 9 ways to lose, so that would be a 10 total ways. So you got a 1/10 chance of winning. The odds against a spinner landing on red are 2 to 3. Okay, so just a reminder here, this is how many ways you not get red, and this is how many ways you get red. Okay, because it's odds against. What's the probability that it will land on red? Well, 3 ways to land on red. How many total options are there? There's 5 total options. So the probability of landing on red would be 3/5 or 60%. Okay? So that is it for 10.6. So again, as always, let me know if you have any questions.